Okay, what type of sensors did we talk about? First of all, what is a sensor? Sounds like a good test question, right? So what is a sensor? Yeah, that's what it does, but what is it? I mean, you're right. That's exactly what it is. It helps the robot sense its environment, right? You understand that? Good reading. So what would you put? How would you put that in your own words instead of my words? Well, probably not. Most of our sensors we looked at is not mechanical. We got one that's what we call electromechanical. But sensors are not necessarily they're not mechanical. They could be electrical mechanical, but they're not going to be mechanical. Y'all understand that?
Part of the robot that uses different objects, like temperatures and feel it,
So what is our senses? So we have sensors, right? We have sensors. We got a controller. That's our brain up here. And then we have sensors. What are our sensors? My brain does not know touch. My brain does not know smell. My brain does not know sight. My brain does not know hearing. But I can hear, I can see, and I can touch. So what are my senses doing? Well, my senses are taking these physical stimulus and converting it over to something that my brain understands, either chemically or electrically, right? Our brain basically processes chemical and electrical information. That's what it does. That's all it does. And then we have different sections in our brain that's responsible for different senses, right? You understand that? Not for processing, for sensing. So a sensor takes some type of physical stimulus and converts it over to an electrical equivalent that the computer can process. So the computer processes electricity. It don't process chemicals. It processes electricity. So it means everything that comes into that computer has to be represented electrically. Does that make sense? So that's what a sensor does. And we have two categories. What's the two primary categories of sensors? Digital and analog. That's good. That's exactly right. Digital and analog. Digital is either going to say it's there or not there, it's present or not there, you're touching me or not touching me, right? You understand. The sound is at a certain level, not the level of the sound, but the sound is at a certain level, right? You understand. So like in your car, your fuel light comes on. Would that be digital or would that be analog? Digital, right? You understand. But your fuel gauge is what? Analog. Right? You understand that? Analog has the ability to vary over a given range. There's always limits of the range that we can vary. Normally what we use in industrial control systems, your analog sensors are from 0 to 10 volts. Of course, your digital sensors are either there or no there. But in control systems or in robotics, normally for digital we use 24 volts and 0 volts. That's our two logic levels that we use to represent all binary information outside of the controller. Now, when we get into the controller, the voltage levels are quite a bit smaller, but that's the sensor. So our digital sensors in robotics usually provide 24 volts and 0 volts for digital, and between 0 and 10 volts for analog. And that's in robotics. But digital sensors can be just about any voltage available. So the computer, these computers use, it has 3.3 volts available. It has plus 5 volts. It has plus or minus 12 volts. So those are the voltages that's available for the computer. So the computer is going to represent those in either one of those voltages. So we talked about sensors that we talked about, of course, were limit switches, right? Everybody okay on those? Those are electromechanical devices. So those fall into a category of what we call contact sensors. And then we have our non-contact sensors, and we have a ton of those. So non-contact sensors mean that the sensor does not have to make physical contact, or doesn't make physical contact with what it's sensing. And sometimes it would be impossible to like temperature. How can you make physical contact with temperature? Right? You understand that? Or light. How would you make physical contact with light? So we looked at analog, we talked about analog sensors, we talked about digital sensors, and these are both available on the Amatro line. The Festo line, manufacturing line, only has one analog sensor on it. The Amatro line has has a few analog sensors on it that's available. The robot that we're going to be using has mostly analog sensors and then one digital sensor. So the sensors that's available for the Hero robot, for the Lego robot, is, there's a bunch of them. You can. I don't know if they'll give us a list of them or not, but we can get gyroscopes, we can get temperature sensors, we can get, I don't know if this would show them right here. So the EV3 has a color sensor available to it. These are just the ones that come with it. A gyro sensor, a infrared sensor, a ultrasonic sensor. Oops, how did I get? Oh, there we go. One of them. An infrared sensor, an ultrasonic sensor, and that popped up while ago. Right? Same spot. A touch sensor, which is a limit switch, but they call it a touch sensor here. And it's Lego, so that's where we'd put whatever operator we want to use with attach out here. And that's all that is, huh?
Limit referred to limit of what?
Originally, these switches were used to indicate the limit of a machine. So, like I was trying to make a milling machine automatic, and then the bridge moved back and forth and back and forth. Well, what it would do when it get to one side, it would hit the limit switch and it would tell the controller to do what? Go back. But what we do now is that's one of the functions of a limit switch. But we use these things to count. What they do is when devices come by, they hit a little operator that makes and breaks the limit switches. So we use these for proximity sensors and what they are. But we don't call these proximity sensors because this guy's was the first basically sensor that we had was a limit switch. And so this guy has its own name, right? This guy has its own name. Normally when we talk about proximity sensors, we're talking about our non-contact sensors that we were looking at. And we can go look at the manufacturing line. It's a lot better to see them. These guys got limit switches all over. And basically in that situation, that's exactly what they're doing. They're giving us the limit of travel that something can go to. But we don't have, I've seen them used as counters. I've seen them used as all kinds of stuff. Presence detectors, you know, why turn something on if nothing's there? Right. So these are just the for the EV3. Now the EV3 is the new version. We're using what they call the Mindstorm, which is the older version. This guy is pretty cool, but it's not much different. If you learn the version that we have, you would pick up on the EV3 without any problem at all. So what we have is we have a controller that they call the brick, and it's obvious reason why they call it the brick, because it looks like a brick. And it has two functions available to us. It is the controller, if I can get it to focus in, and it's also a method of what we online program. So the first programs that we'll develop for the robot is online program, which means we're going to teach the program at the teach vendor, right? You understand that? But it's a very, there's a limited amount of memory inside this controller, so the online teaching is very, very limited. Basically, what we're going to use it for is we're going to use it while we're building the robot. We're going to use it to verify the steps of the assembly process. So when we add a sensor, we're going to do an online program that checks to see if that sensor is doing what it's supposed to do. To get the full-blown capabilities of this robot, we'll primarily use offline programming. Y'all understand the difference? So what's online programming? Yeah, at the robot itself. And offline programming is what you're doing with the Hero robot. So the Hero robot, you're writing your programs over here, you're developing your programs over here on your computer, and then you take it from the computer and upload it into the robot controller. So all these robots here support online programming, and then you have to have a special application that you use to do offline programming. So to do offline programming, for the Hero robot, it's really neat. We're just using Notepad or WordPad, whichever one is available. I think on this one, Notepad is available. So we use Notepad to program the Hero robot, but the Lego robot we program using, y'all got it on y'all's computer if you're logged in. Somewhere on here it's called NXT 2.1 programming. This is the programming language for this robot. This is a GUI, or graphical user interface. This is a graphical programming language, which is pretty neat. If you're taking the operation and programming class in Mini-Term 2, that is what we call a script language. It programs in text. Here we're going to program in blocks, in Rails. So this is where you would put the name of the program that you're going to create, or by default it comes up and gives you. Default in computers means what your computer uses if you don't tell it differently. So normally computers have defaults built into them. That way you don't have a lot of syntax errors. It'll stick something in there until you go back and do what? Change it. So over there on these robots, if I tell it to do a move, it's automatically going to give me a speed, and it's going to give me a round off, a accuracy of the point, because that's required by the instruction. So when you stick it in there, it's going to do that for you. And then what you would do is you would go back and change it. So I'm just going to use untitled. I'm not going to say it. And this is the program. This is the programming for the Lego robot. And what we have on the left over there is, this is what they call the standard palette. You can do a lot of stuff, which we're not going to get into. But we're going to use what they call the standard palette. So this is all your math functions, your decision-making functions, and all kind of stuff. And we just don't have time to teach it. So this is what we call the standard palette of instruction. Now what we have on the brick is we have portals. We have 3 portals across the top. They're called A, B, and C. These are your output ports. I'm sorry, these are I/O ports. So an I/O port is a portal that supports both input information and output information. So what we're going to do with this is we're going to hook up our servo motors. And what's a servo motor? Yeah, it's a motor that provides feedback. Yeah, so a servo motor has to be connected to basically some type of I/O port, right, to understand. So they're labeled ABC, and we're going to connect our motors to it. We got 3 motors that were servo motors that we'll be using. But you know, it's up to you. You can set these ports up, and we'll look at this later on. But by default, they come up to be set up for these servo motors. And then across the bottom of the brick, this is our input ports. These are input ports. And of course, what are we going to connect to our input port? Well, this is where we're going to connect our sensors across the bottom. They're labeled 1, 2, 3, and 4. And literally, you can connect them any way you want to, but what you're going to start off with is it's going to tell you what ports to use. Are we okay so far? Everybody okay? And then all we got on the T-pin on the controller itself is 4 buttons. And then the orange button is what we use to turn it on. And that's why you know it's on. And then we also use it to select. So turn it on, and if we want to select something, that's what we hit, right? Does that make sense? Okay. And then once we get a menu item selected, then we use the arrows to go through the menu. So the menus are horizontal. So if y'all can't see that, this is an option in the menu called Try Me. This is what you need to. So if anytime you hook up a sensor, this is where you would go to see if the sensor works. These are programs that are built into the controller, so you don't have to write programs to do that. So if I wanted to come up here and check my sound sensor, then I could come up here and say Try Me, and then I'm going to use my keys to come up, and it says Try Sound. So I'm going to come up here and turn that on. So I selected it, and then it's going to ask me, do I want to run it, and I'm going to run it. And what they're doing, they're what it's doing. So this is the sound sensor right here. And what the program is doing, it's running the motors proportional to my sound. So the louder I speak, the faster they run, and the slower I speak, the slower they run. You'll see that? So that's just a program that you can use to say, okay, is my sound sensor working? But these are going to depend on these devices being hooked up to a port. So it didn't ask you for the port number. All it did was say, okay, by default, this is where they're supposed to be connected to. Does that make sense? So I could try the ultrasonic sensor, and you can see it's an analog sensor, right? It's an analog sensor because it's sensing the volume of my sound, and it's running the motor at a speed depending on the sound. And of course, if I want to go back or stop anything, then we hit the gray button on the bottom. And then to get back to the menu, that would give me back to the run option. To get back to the menu, I'd have to hit it twice. So what we can do here is we can check out all our sensors. Try sound, try motors, try ultrasonics. So I'm going to hit it once to select it and hit it again to run it. So now it's checking out the ultrasonic sensor.
This measures distance.
This measures distance. And what I'm doing is I'm moving the ultrasonic sensor up and down away from the table.
And the pitch is what?
And the program is changing the pitch, indicating a distance. And we can do that with all our sensors. We don't have the tricolor sensor, by the way, with our kit. Another thing, option we got available. So so to go back, once I'm in a menu, to go back, I hit the gray button. Right? You understand that? Oops. I just turned it off. So I'm going to go to an option over here that says View. So this is the option in our main menu that says View. I know you can see that my camera won't focus in on it for some reason. And then what this does, this allows us to actually look at the output of these analog sensors. So I'm going to go over here and go to the ultrasonic sensor. Now here it's going to ask me what port it's on. So you have to know which port it's connected to. We're connected to port 4. And now it's telling me centimeters. So I'm going to come up here and I'm going to come down and it goes, so this would be 6 centimeters. And then, I don't know where it leaves out, that would be 22 centimeters. So here we can actually use the thing to make measurements or measure the amount of sound, right? You understand? We'll use these to calibrate our sensors, which I'll show you that in a minute.
So when do we start this project?
We're going to work on it today.
Great.
The first thing we're going to do is we're going to do a sensors lab. We're going to play around with the sensors on the Lego robot. Well, first of all, we're going to go over to the mechatronics lab and look at all these different types of sensors that we talked about.
On which one?
On both of them.
Oh, okay.
We'll look at it on both. And see what's required for automation. But when we come up here on the Lego, then this is, what would you think this would be? Well, this is for motors, and what we do, and by the way, you don't have to hold and drag on this. If you move it, you just need to select it. And then, if it's blue around it, it means it's highlighted or it's selected. If you want to get rid of it, you can just hit the delete key. And then what we do is we come down and we just click on what we want. We don't have to drag it. And then you can move it where you want it. And what you're going to have to do is attach it to the rail.
How did you get rid of it?
I just selected it and then hit delete on the keyboard. So notice it's got a blue line around it. So if I come up here and start dragging stuff down, like I want it to say something, notice you have to attach it to the rail. Okay, and the rail automatically extends as we move forward. Right now I have this guy right here, and this is going to make the robot say some sound. Well, if you want to make it say something, we're not going to show you how to actually make a recording. All you're going to do is you'll just come up here and use some of the phrases that's already built into the program. And then you can control the volume. But if I wanted to get rid of it, then what I would do is I would just come up here and click on it. And that's, when we say click, by the way, on these computers, that means the left mouse button, right? You understand that? And then notice it's got a blue line, it's got a blue outline around it. And then I'll just hit the delete key on my keyboard. and you can insert in between. So if I came over here and says, okay, I want to insert something in between, then notice as I move it, can you see the gray line, little gray thing that pops up there? And that's where it's going to be inserted at. So you can insert, you can delete, so that would be the way you edit the program. Now if you keep adding boxes, these are our sensors, by the way. So let's say I add a touch sensor, and then I keep adding boxes and different things. We'll talk about these. Y'all won't need these right now. Eventually, we're going to run out of space over here. Well, what you do, you just use your arrow keys. You can just use your arrow keys, and you can advance this. So now I'm using my right arrow key, and you can go way over here. I'm using the left arrow key to bring it back. You can use up and down. See that? And we'll talk about these others. You're not going to use any of these to start off with. We'll come back in here and give you more details about looping and decision making and all kinds of new kind of stuff. But if I want to get rid of this, I just highlight it, and then I do what? Delete. Yeah, I press delete on the keyboard.
Is that a test question?
No. This is strictly for this robot. The test is not. The tests are not written where you're going to do a lab on.
Right.
And you're going to find out you'll want it. We call it editing the program. That's taking a program and making changes on it. So what I'm going to do is I'm going to bring up one of the sensors. So here's our sensor that's down here in the hourglass right here. And while they gave it that, there's only one thing that's not a sensor. This is a timer. So this is where we could put delays into the program. So these are the sensors that's available by default. So here's our touch sensor, here's our light sensor, here's our sound sensor, and here's the ultrasonic sensor. So if I wanted to put the touch sensor in here and put it right there, then we get down here at the bottom, we get these options. By default, it's going to come up with the port that it's supposed to be on, but what can you do? You can select any of the 4 ports. So when you assemble the robot, when we finally get to assembling the robot, the assembly is going to have you put the sensors on it in the right order. So the defaults will be used. But later on, when you start modifying your robot and you want to add another sensor, then you can hook it up to any port. When you bring in that sensor, it's gonna give the default, but then what can you do? You can put it on any port you want to. So this identifies the port down here. Then it says, okay, what am I going to do with this digital sensor? Am I going to look for it to be what? Pressed? Am I going to look for it to be released? Or am I going to look for it to be bumped? Bump means, so pressed and released, right? You understand that? That's what they mean by bump. And this is where, so if you didn't have these 4 basic sensors, but you went out and bought another sensor, then what you have the ability to do is just drag any one of the sensors you want, and then you can come down here, and we're not going to have to do, I'm sorry, we're going to come down here, but here, and then this is all the sensors that's available for this robot. So this is where you would select a sensor that is not part of one of the 4. Y'all understand that? Of course, we're not going to use that. I'm just showing you some of the stuff. Now, the only sensors we're going to use are one of these 4. So this is what, these 4 sensors are what comes with the kit. Now I'm going to bring an analog sensor in. Let's say a light sensor. Now notice what they have here. So first of all, it acts for the port. But what we're going to do is the analog, the digital analog to digital converters are built into this control. So what we do, if I'm using an analog sensor like the light sensor, and I'm bringing it into a digital computer, then we have to go through what we call a device called an analog to digital converter, right? We talked a little bit about that. And of course, we have what we call digital analog to digital converters, which basically switch at a certain threshold. But just about all these sensors where the sensing element is analog gives you the ability to set that threshold, which we refer to as a sensitivity. So right here, this is where I set the sensitivity. This is where I say, okay, I'm either looking for light or I'm looking for what? Dark. Right now it's set up to look for light, and this is where we set our sensitivity. You can set it by the slide, or you can come in here and set it numerically. So you come up here and just enter a value if you want to. It's up to you. So that's so what we just did is set the sensitivity of where it sees that light reflected as either a what? A 1 or a 0.
Because that's how analog is.
That's the analog to digital, right? But it's the digital, this is a digital analog to digital converter. We do have ones that actually gives us a long binary number that represents an analog quantity. And this robot, this robot don't support that.
So, all right, I have a question. Sorry, you said it's a quantum?
I didn't say quantum.
What did you say?
I might have said quantity.
Quantum, okay.
Oh, y'all can see. This is where if we want the display to come up and display something, and it's got several images available. So this would actually pop up on the display.
What's quantum and binary to these?
Good question.
I don't know. Quantum and binary.
We took this physics, it was light, heat, and sound, and mechanical physics. And what we do here is this is where you can actually set the position on the display. So what we'll do is we'll come up here and make it say something. So what do we want to do? So I want to come up here. If I hit the touch sensor, what do we want to do? Let's come up and say we're going to turn a motor on. By the way, notice anytime you click on the actual icon, then this is where we control that device. So what can I do with a motor? Turn it on or off. Well, yeah, no, these are servo motors. So what can we do with that? What should we be able to do with that servo motor? Speed, we should be able to control the speed, and we should be able to control the distance or the rotation, right? Understand that? Yeah, we should be able to control the direction. Yeah, they reverse. So right here, this is the direction, so that's good. So right now we're saying, okay, when this happens, I'm gonna run motor B and C. I could run motor C. I could run the motor hooked up to port C by itself. I could run the motor hooked up to port A by itself. So let's run the motor hooked up to port B. By the way, notice when I take off port C, we lose direction. Because you can't make a motor make a turn, right? You understand that. And when they're talking about direction here, we're not talking about forward or reverse. We're talking about making a turn. If I run two motors, then what we do to make a turn is you just change the speed of the motor. So what you can do here is you just come over here and slide this, and this will automatically adjust the speeds of the motors to cause the robot to turn in a certain direction. This is where we control the speed. So right now, by default, it comes up and runs the motors at 75% of their speed. How does it know that? Well, it's got a speed sensor on there, right? You don't understand that. this is where we either set it as an open loop or closed loop. So right now it's going to run one rotation, or it's going to turn 360 degrees. So I can specify the number of rotations, or I can specify the number of degrees. Those two we would be running the motor as a closed loop system. Or I can specify to run it as unlimited. So unlimited is open loop, right? So we're not using the sensor to sense position. What we're doing is just turning the motor on.
Each wheel has its own motor.
Yes. Yeah, this is the servo motor. Well, that depends. So you can't say each drive wheel has its own motor.
All four. How many wheels are there? Four?
No, we got 3 motors. So everything we do, we're going to have to do with 1, 2, or 3 motors. You could. You could just turn one. It depends on what type of turn you want to make. If you stop one and turn the other, then you're going to make a sharp turn. If you run one slower than the other, you're going to make a gradual turn, right? You understand? So it all depends on what type of turn you want. We can run the motor unlimited. This is open loop. So the position sensor is there. It's just that the controller is not using it. We can run the motor for a certain amount of time. Is that open loop or closed loop? Open loop, right, exactly right. That's open loop. Here we're running it. So if I run it a certain number of rotations, or I run it a certain number of degrees, that would be using closed loop, using the sensor, right? You understand that? If I run it for a certain amount of time, or run it unlimited, those are open. So if I want to make it go over there and follow a line, that we're going to run that unlimited, right? You understand that? So we're going to depend on the sensors to change the direction of the motor, but we don't want the motor to constantly go on and stop. So right now we're gonna put this in the robot. We could do this by Bluetooth. But we don't have Bluetooth on any of our computers for obvious reasons, because y'all be connected to it all the time. Or we could run it. We can connect it to just a USB connector, an A type connector, a B type connector, sorry, this is a standard B. So when I come over here and look at the top of my robot, you see it's got a standard B type connector. Oops, as soon as I get on there. So here it is at the top. So I'd connect it to one of the USB ports on my computer, and I'll connect it to my B connector. It's labeled USB. And then we just come up here and we can download it. This button here in the center, what this does is this downloads and runs. That's not good to use, because a lot of times your robot will be up on your table and you download a program and the motor kicks on and it jumps off the table and it's Lego. What'll happen when it hits the floor?
It smashes.
Yeah, I say it'll go 100,000 different ways, right? You understand? You could screw up the controller. So don't use that one. This one right here downloads the program. So I'm going to download the program. And the robot controller will beep at me once it takes the program. Compiling. And we can't put it in this controller. Why? Oh, y'all didn't see the error?
That's all there, but
Says it's what?
I don't remember.
If it don't take it now, there's something, I have to figure out what's going on with the controller. I could reset it and see if it works. Okay, so it beeped at me, and that means it took the program, right?
So the problem was, or you had
Yeah. So that's something I'll probably need to check once we've got the kit. We're going to inventory the kit, and then you'll bring your controller up to me, and I'll delete all the programs out of it. So I don't know how long this has been in there, but oops. So by the way, if you keep hitting the gray button, eventually you'll come to this screen right here, and this says turn off. And so you can either go to the X, which means you don't want to turn it off, or you can hit it and that turns the controller off. You need to get used to doing that at the end of every class, because if you leave it on, you're going to come back next time and your battery's going to be dead, right? So orange button to turn it on. And when it comes up saying My Files. This is where the programs are put at. You click this, and it's going to say Software Files. I'm going to click that, and then it should be the name of the program that you entered when you developed the program in the Mindstorm software. I'm going to select it, and then now it's running. So the program's running, and what was the first thing in the program I wanted it? What did I tell it to do?
Turn on?
No, I didn't.
Touch
I said it looked for the touch sensor, right? I'll say that. So it's sitting there in that program waiting on me to do what? Touch the touch sensor. So I come over. Go ahead. I'm touching the touch sensor. That sensor right there.
Well, it had a little thing on it.
Yeah, so here it is right here.
Yep.
And as soon as I touch it, the motor comes up and runs one revolution, which is what we told it to do, right? Motors B and C came up and ran one revolution. Now it's out in the program somewhere. It depends on what the program said do. So the program said, so it's sitting here on the light sensor, waiting on the light. So it turned the light sensor on because I set it up for, so it's sitting on the light sensor, and it's waiting on a certain amount of light to be reflected back. And I don't know what it was. I don't remember what it said. And then once it hits that, it will continue on in the program. Unfortunately, I don't think I told it to do anything else. I told it to record, so we didn't want that in there. I told it to play a sound. So let's say we'll make it say goodbye. I want to put it back in there. So by the way, once you got your program in there, you can disconnect the USB cable, right? You understand that? So now when I get the light sensor, when it gets to a certain value, it's going to come up and should say goodbye. So we'll see this. I'm going to put it in the robot again. So it beeps at me. By the way, when you do this, it replaces the other program. Then I'm going to run the program. I'm going to back out of it. Select it and run it again. So it's running. What's it waiting on? According to my program, it's waiting on the touch sensor, right? Touch the touch sensor, the motors are going to run one revolution. They stop. And now what's it waiting on? Waiting on the light sensor, hopefully. It's not doing anything. See where we got that thing set at. Light. Oh, you just saw it. So we were setting it for greater than 50 seconds. Y'all didn't hear it say hello, did you? So it was looking for reflective light. So these are the first programs you're going to write, these straight line programs. We can do a lot with this robot. This robot will multitask. Y'all know what multitasking is?
Maybe at once.
Yeah, so you can literally come down here and put another task down here, and then you can string it over, and it's going to do those two things at the same time. So we can multitask this robot. You're not going to, it's up to you whether you want to try that. The programs that we're going to have you do, you don't need to use this feature. You'll hear some of mine. Mine will be moving around the track and be laughing at you and that kind of stuff. Well, that's because it's doing what? It's running two programs. It's running one program that laughs at you and one program that's running the motors. And that would be a little example of multitasking. But you're not going to have to do that. These are just the features. What you're going to do to start off with is I'm going to tell you to put a sensor in your program and then have something respond to it, usually the motors. So we'll put this and have the motors go forward. We'll put this and have the motors run in reverse. We'll use that sensor and run the motors in different directions. And that's the only thing you're going to do in this lab. Is just do what? Just see the sensors. That way later on when we start doing these programs where we have to stay within a boundary where we set our robot up to free roam, which is means we just turn it loose. Like y'all saw my robot when I put it the other day, it just did what? It just roamed around, free roam, didn't run into anything, just free roam programs. We'll do a program where you'll make it follow a line. We'll do a program where you'll drive a golf ball. We'll do not a golf ball, a plastic ball. Our robot don't have the springs to drive that. Well, we'll do a program where, and we're going to compete the robots. We're going to compete them also. So that should get us ready, and we'll give you more detailed information when we actually more features of the robot. This is offline programming. So what's offline programming?
Not online.
I'll do it over here.
Huh? No, offline.
I'll do it right here.
Yeah, we're going to do. This is what I'm doing right now. I'm doing offline programming.
It's not connected to the internet.
Well, it could be connected. Offline means we program away from the robot, and then we upload the program into it once it's been developed.
Okay.
Online means you're programming at the robot.
Gotcha.
So in your sensors lab, the sensor lab that I'm going to give out, where you're going to deal with this, the sensor lab is online, but you're not doing programming. Excuse me, we're not programming yet. What we're going to do, first of all, is we're going to use the features that's built into the controller to check these things out. But the very last thing you're going to do in the sensor lab is you're going to write an offline program. And what I tell you, you're going to have you do what? It's going to have it look for a sensor, and then you're going to do something physical. You're going to run a motor depending on on it seeing that sensor. Okay, does that make sense? Everybody okay? Any questions?
Can we take a break?
Yes, y'all got to take a break. When y'all get back, we'll come back and go over to the manufacturing lines and look at the sensors. One thing I didn't show you how to do is save the program. If you come over here and click on exit, it's going to save it on the hard drive on these computers. We don't want to do that, right? You understand that? So normally, how do you select where you save on the Windows application? You come up here on File in the upper left-hand corner, and then you're going to choose Save As. And here you can change the name of the program. If you don't like the name, you can change it. And then what are you going to do? We'll click on Browse, and then you're going to come up here and point it to your USB drive. So you don't have to have your USB drive in the computer. So what you're going to do is you're going to save your programs on your USB drive. That makes sense? And that way you're not giving something free to the next class that comes in here. But somebody does this wrong every time, by the way. So what I'll have to do, it's basically a standard Windows application. So normally in the upper left-hand corner on a Windows application that allows you to save and load documents, we have a listing called File. And we click on File. If you put Save, it's going to save it the last place it was saved at. So what, the first time what you want to do is you want to do what? Save as. Then this little pop-up will pop up. This is the name of the application. Right now it's untitled, but you can rename it. So if you don't like the name you gave it when you first started, then you can change the name right here. And then what you'll do right here, you're going to choose what? Browse. And then you're going to come up here. You can go to My Computer. I usually don't do that because it's right here too. You can go to My Computer, and then you find your USB drive. So you need to have your USB drive in the computer, right? You understand? And then point it to your USB drive, and then you save it there. After that, once you've established the path for the file, then you can just hit save, and you can exit the program from now on, and it'll save it in the right folder, right? You understand? But you have to establish the path. If you don't establish the path, then what it's going to do, it's going to save it in the Lego folder on these computers in here. And then what you'll find out the next time. So I'm going to go up here and just save this. I'm not going to save it on my, but save as. I'm going to leave it as untitled. And then I'm going to go over to the folder for this class. And that way. And then once I come up here and save this, and save, then I can exit the program. Now from now on, what happens when I load the application? Then what you have at the bottom, so as soon as it loads, what you have at the bottom, right below, so this, I use this to create a file. I use this to do what? Open a file. And what it does is it comes up and shows me the last application I have, but it keeps the path for me. So that means I can come up here, all these other programs. So I'm going to load in one called Follow the Line. And so this is a program that actually it follows the line. This is my program.
You stay down on the ground. Like,
yeah, what we're going to do is, that's what this tape right here is for. So since we've got a dark or dark gray floor, then we're going to make it follow a white line. So I'll go up here.
Adjust the sensor to see white light or white.
Right, that's what you'll do. You'll use that, and we'll show you all that how you do that. You calibrate the sensor. So what you'll do is you'll go over there and you'll put it on the white line, the white, and then you'll see what that sensor puts out. Then you'll put it on the gray, and see what that sensor puts out, and that's where you'll set your limits in the middle. So that's where we'll use that view option. Like I said, we'll show you all that. And once we get the line out, so this program multitasks, and this is what we'll learn how to do this later on once we get into a little more detail. The first program that you're going to write, though, is just going to be a program that utilizes the sensors. It's going to say when the touch sensor is made, press, turn on this motor. When this sensor's pressed or detected, then reverse the motor and stuff like that. So yours is just going to be a straight line program, and not a looping program. So what this is it tells the programs to constantly loop. So what your program will do, when it gets to the end, it'll just stop. And what this program does is that's a loop right there. So what this will do when it gets right here, what will it do? It'll just constantly loop, because we're following a line, right? To understand that. This is a decision-making loop right here. So it says, if it sees light, take this path. If it don't see light, take that path. Or if it's below the threshold, take this side. If it's above the threshold, take that side. One of them is going to turn the robot this way. One of them is going to turn the robot that way. And that's going to make it follow the edge of the line. So later on, we'll look at this and see more in detail what we can do with this. This is a really powerful programming language. But what's nice about it is visual. It's a GUI, or graphical user interface. When you get over there and program them suckers, there's no graphics at all. It's a text-based language. So now you got to understand syntax. Here, I don't really have to know the correct way of writing an instruction. All I got to do is drag a block down. And then what I do is I make changes depending on what I want to do. So what this does is it constantly makes the robot laugh. And it repeats it every 3 seconds. That's all that does.
Turn the button off button, stop that in there.
No, you just pick it up. Pick it up and stop it. There's no, if you're going to have to pick the robot up to press the stop button, we could that. We can monitor every button on the front. So right now it's got default setups, but we can make it do different things with different buttons.
When you pick it up, it doesn't lose that. It just stops that.
No, what you do is you pick it up and hit this black button, the gray button to turn it off. You say, well, I could put it in a program to hit the gray button, but there's really no reason, there's really no need to put it in a program if you're going to have to do it anyway. So what you do to stop the program is you pick it up and hit the dark gray button. And as soon as you hit that, the program will stop. So that's a good question. Normally, if we got a loop, sometimes we put a stop, something that stops it in there.
Well, when you would say, what program is right,
Straight line, which means it's,
so it gets to the end,
it stops it. Since we don't tell it to loop, then when it gets to the end, it just stops. So none of these robots use a stop. What we have a button on our teach pin called hold or stop or something like that we hit. And that is controller based, right? You understand? So normally you don't want a robot to stop, to be programmed to do what? Stop. You can pause it and make it set still, but it's always waiting on something to pounce. By the way, you can load multiple programs in too. So I'm going to come up here and I'm going to open. Where was the program we just, let's see, let me find it. Labs, yeah, here labs, and untitled. So every time you open up another program, what it does is add another tab up here. You can't put 2 programs in the robot at one time, but if you're switching between programs, you can do it this way. So this is what I call a straight line program.
You got a reprogram you want here and then
Yeah. But the robot only has one program running in it at one time. You can download multiple programs until you run out of memory. So whoever did the last program on that, they had a used program. It's a pretty good sized memory. So odds are every program that you write in lab, you'll be able to put it in the robot without wiping something out. If I wanted to get rid of a program, and don't wipe out anything that don't belong to you. So what I do, notice when I select, so this says software, I'm going to select that. Then it says untitled, I'm going to select that. And then I'm going to come up here and hit run, hit this and run. But notice right before I run it, I don't know if y'all can see it, there's a little garbage can over here. You'll see that? So if I wanted to delete the program called untitled, then I could come over here and just move over to the garbage can and I hit my orange button and then it says, okay, do you want to delete? By default, it comes up and says no. I'm going to move over to the check mark and delete it. It's going to give me a couple of chances if I deleted the program. Now, I didn't delete it off of Mindstorm. I deleted it out of my robot. So what we're saying is if you run out of memory and you need to put a program in there, then go ahead and delete one you've already got in there, put your other program. If you want to go back to that one, you'll just download it. You just go back and download it, right? You understand that? This robot controller doesn't have a lot of memory. For obvious reasons, it's a little old tiny thing, right? So it might run out of program, especially when you get into that where you're doing your own programs to win competitions. So if you're doing your own program to win a competition and it runs out of memory, don't get upset, right? Just go in and do what? just delete the program that's already, some of the programs that's already in there. So you could put one program in there and you could put a really good sized program. It's just what we're going to have in there. We're going to do a free roam program. We're going to do a stay inside a boundary program. We're going to do a follow the line program. We're going to do a maze program. We're going to do the driving range. We're going to do a driving range program. So we'll set up feet markers on the floor, and then one of the competitions you'll try to see if your robot can approach it using sensors. And every lab that we do, you're going to use a sensor. So what you'll do is you'll use a sensor to approach the golf ball, and when you get up to a certain limit, you'll stop it, and then you'll tell it to do what? Swing the club, and you'll drive it off the tee. Now we'll show y'all. We've got all the programs out there, so I'll take the robot, show y'all the one that we built, and then show y'all every one of these programs, what we expect y'all to attempt to do. The follow the line program, we'll give you a few hints on that one. All the rest of them, guys, it's up to you, because they're basically very simple programs. Well, that's not true. They're very simple for a programmer, right? People have been dealing with programming for a long time. Yeah, probably. These kids that's been playing around with these iPhones and stuff like that, you give them one of these things, they would love it. But you're talking about a $300 investment. For the whole kit, we have what they call the educational package. Ours doesn't have as much stuff in it that comes with the whole kit. The EV3 is a really, really neat robot. It basically still has the brick, and then it comes with the same sensors, but instead of having a regular shades of gray sensor, which is what ours is, our light sensor, it has a color sensor, which means you can make it do different things, and it sees different colors, which is pretty. So okay, so let's go next door and identify all these sensors that we've been talking about. We're going to do the sensor lab. And you're going to do it in a team, just like you did before. Odds are when we get, what we'll try to do, it's going to be hard with the class this size, and we'll let everybody build their own Lego robot. So what we got here, so in the lab where it says you're supposed to have the kit right now, we're not going to use the kit. Everything you need is over here against the wall. All your sensors are in the white boxes. The controllers are the bricks over here on the right. We got 6 out there, and there's 11 in the class, so they should be plenty for everybody. Everybody's here. All your cabling, your servo motors are down here. In the lab, listen. You need 1 controller, you need 3 of the servo motors, 1 each of the sensors. So we have 4 sensors. We have a touch sensor, sound sensor, optical sensor, and then the distance sensor. 1 each of those. You need 6 batteries. Batteries already in there. Yeah, but y'all gonna work in teams, right? No more than 2. We'll just ask, we don't have partners. Somebody, you got 11 people here, somebody's going to. 6 cables. I'm sorry, 7 cables. We got 4 sensors and 3 motors. When you add them together, you come up with 7. No. All stuff there. Everything you need.